All right, welcome, ladies and gentlemen, to week number 93. My name is Mr. McLogan, and the title of tonight's live stream is When You Suck at Math, Do This. Now, I'm using some pretty strong language, you suck at math, rather than maybe say you stink or you're bad at math, because it's something that I am really, really passionate about, that I really want to emphasize with you guys when you are going through math, because I know a lot of students that are on this stream or follow my channel, they have some times when they struggle with math. So what I want to do is cover that kind of topic of when you have that, faith, that feeling that you are sucking or stinking or being bad at math. What exactly do you need to do? And then, as always, guys, we have a ton of questions, not a ton of questions, but roughly around like 10 questions I'll go ahead and get to. And you guys can see inside the chat that I have a link where you can go ahead and submit questions that I'll answer each and every Sunday night, as well as a Discord server where you can go ahead and join that Discord server. And if I can't help you with your math, there's a ton of amazing and smart people on there that can also go ahead and help you guys out. But I just wanted to say welcome to Hilaire and Pranaf and Tribe Death and Black Empowerment Vision, Swirl on Console, and Christy. It's good to have you guys on the live stream. Thank you so much, guys, for joining me tonight. And let's see why that is looking. That's weird. So yeah, we will definitely get into, I am happy to be live, or not having to go through a whole bunch of live streams like I did last week when I was releasing my course. But just want to let you guys know, if you are still interested in joining the course, that's definitely something that you can go ahead and still do throughout the year. I know some students maybe might not be struggling with pre-calculus, at a certain time. So whenever you need to go ahead and take a look at that, all the details are at brianmclogan.com/pre-calc. And hello, Ben and Scared Out Hot Dog and Fenan Gada. All right, let's go ahead and answer some of those questions before. Actually, let's go ahead and get into this. What we're going to do is let's get into the math or the topic. And then what I'll do is I'll answer some of your questions you guys have. All right. So if you guys do have some questions or just general questions, I'll go ahead and check a look, and then we'll get into the math. And then depending on how much time we have after that, I'll go ahead and answer some more questions with all of you guys. So let's talk about the sucking math. And the reason why I chose the word suck was actually very intentional, because it is a strong word. And it's actually a word that a lot of students will actually say in their head, right? They say, oh, I suck at math, right? Or I'm not good at math, or, that's what people are saying to men. And so even though they might not, it might not be the best title or the best word of vocabulary, it's what people are using in their brain to describe how they feel with math. And the one thing I want you to know, and I want you to listen to this very, very carefully. When you feel that you suck at math, or that you can't do math, or you are bad at math, I want you to make sure that you are asking as many questions as you possibly can. Ask a question, ask a question, ask a question. Because I think the main thing is people believe that they aren't good at math, and then that's something ingrained, right? Hopefully you guys talked about the fixed mindset, the growth mindset, and going from there. But I think the one main thing is people feel like when they're not successful in mathematics, like that's set in stone, like they cannot improve. They do not have the ability to be good at mathematics. And that is absolutely 100% incorrect. I know that every single student, regardless of when they struggle with math, can overcome those struggles. They can learn this material. The problem is we just compare ourselves to either other people or, how things were supposed to be done or how things are expected for us to learn something. And we make it feel bad about ourselves. We make it feel bad that we can't do the math. And the one thing I have found, and I don't have any research on this direct correlation, but the one thing I can definitely tell you as being a teacher inside the classroom, the students that ask the questions, the most amount of questions, are the students that are going to be successful regardless of how much they understand and don't understand in math, right? It's okay to struggle in math. It's actually like perfectly normal to be struggling in math, right? But the main thing is when the same kind of thing, like, when you fail, it's like, what do you do after that, right? It's like, how do you bounce back, right? That's like a sports analogy. Like everybody's going to lose, right? It's not important. It's not really the matter of losing. It's like, how do you respond to that loss? Well, ladies and gentlemen, like in learning, it's the same thing. It's like you're going to not understand everything at the first time, right? It's going to happen. So, but the thing is like, how are you going to respond from that? Like, what questions are you going to think in your head? And are you going to do something with those questions? Like, are you going to write them down? Are you going to ask them? And I totally get it. A lot of students, they don't want to ask questions. Their teachers are intimidating. They don't want to feel stupid, right? So, but the thing is, you have other opportunities to get around that, right? You can go on, like I said, my Discord server where you're kind of like anonymous and be asking questions there. You can watch videos online. Obviously, many of you know me from that, right? And, just try to learn from there. But the main thing is like, ask those questions. Don't just assume that you can't learn this stuff and then you're not going to further investigate why you're not understanding it. Why is it so hard, right? And when you learn something, just don't just assume, oh, well, I can do this. Like I'm good. Like further, like dig a little deeper into the concept. Like why is it doing it? Why does it work this way? Like why do I need to know this? Like, how does this relate to what I already know? Because I think the main thing is if you're not asking yourself those questions, what eventually comes back to happen is you're not really developing a good sense of what exactly you're doing. And then when you start to struggle, I think the worst thing you can try to do is just avoid that you're actually struggling. You can just pretend that you actually know what you're doing when you really don't. And you can get by a class or two, right? It's possible. For any of you that know my story, that's kind of how I started. I just kind of started avoiding things. And guess what happened? Eventually, I came into pre-calculus in high school and the rubber hit the road and I just bombed the class because I didn't know what I was doing. I didn't have the foundational skills that I was supposed to. I was faking it. I wasn't asking questions. And it wasn't until I got into college that I realized that, hey, I want to become a math teacher. And I'm like, oh crap, I got a lot to learn. And so therefore that like set me up on this mindset of like asking questions over and over. Like, am I sure to do this? Oh, I know how to do it this way, but do I know how to do it this way? And then, why does this work? How does this work? How can what if I apply it like this? What will happen there? Why does it work like that? And I think that curiosity, that's one of the big things that I'm, very big push on for teaching is always trying to stay curious. And always trying to, just don't accept the information. Be curious on why you're being fed this information and how it's going to apply. But another thing that kind of came to mind when I was writing the email out was a lot of students a common conversation that I have with student inside the classroom would be, I don't know how to do this. And I'd say, well, what don't you know how to do? I don't even know. And I'm like, well, ask me a question, right? I'm just telling you guys, hey, it's so easy. Ask questions. And I'd say, hey, ask me a question. And they say, I don't even know a question to ask you, right? And then you're just like thinking, okay, so you don't know what's going on. You don't even have a question to ask. You don't even know what to ask me. And then it's like, all right, we got to dig deeper. And I want you, and then so what I would have to do is I'd have to stop. I'd have to say, all right, well, let's start from square one. And we'd go back to the beginning of the lesson. And I'd say, all right, do you understand this equation, right? Do you understand what an equation is? We literally would just build up the whole lesson from the beginning. But once I said something or once I did something where the student didn't understand, they'd say, oh, but yeah, why'd you do that? Or how'd you do that? And a lot of times we could see is these little misconceptions, right? So a lot of people take this, I suck at math, as like, I can't do it because my friends are understanding it or they're already in the class and I'm getting a B or a C or a D or whatever. But a lot of times when you really dig deep and you really break it down, a lot of them are minor misconceptions or maybe things that you learned but you forgot or you learned it but maybe you just didn't learn it in its full capacity or have a deep understanding of it where you could further apply it in another course, right? So realize that when you have these struggles in math, when you're not understanding something, when you feel like you are sucking, you're stinking, you're bad at something, ask the questions. Try to figure out why is it you're not understanding it? Because I can tell you, more likely than not, it's not because you just are not capable of learning the math, right? Of course, if you are in third grade and we throw you into an AP calculus course, more likely than not, you're going to be completely confused because you don't have the foundational math to be successful, right? But the majority of you have gone through a process, right? Good or bad, throughout the years, building up on some skills. And obviously not every single thing is going to be taught the exact or has been retained exactly as you need throughout those years. There's going to be some gaps. There's going to be some holes. But I think it's important that you understand that it is, your duty, your job to say, hey, I'm not understanding this. I need to figure this out. Ask those questions and keep on and just stay curious. And I think that's a major important thing, because I think when you recognize that you don't suck at math, you just need to figure out what to do to get better at it. Then that change in that mindset allows you to be successful. Because when you just say, I suck at math, or I can't do this, or I'm bad at math, or I stink at math, what that does is that just says, oh, that's it, done. Like there's nothing else you need to do. You don't need to try anymore, right? Because you're bad. You're bad at math. Your mom was bad at math. Your dad was bad at math. All your cousins, all your sisters and brothers were all bad at math. So guess what? You're bad at math. You don't need to try in your math class. And there it is. It's done. Nothing else to do. And if you're going to go by that mindset, then again, guess what? You're going to be bad at math. And so, it kind of comes to the thing is like, you're not bad at math. All right. You need to dig deeper. You need to understand, where is it you're struggling? Why is it you're struggling? And dig into those concepts. And you know what? I guarantee you put in that time, you put in that effort, ask those questions, then you can be successful in mathematics. So there you go, ladies and gentlemen. That was a little bit pepped up, but something that it really, really resonates with me, because as I mentioned, guys, I struggled with math, when I was growing up, and I taught a lot of students, and that even they were in my pre-calculus class or my AP calculus class, they felt they were upper level and they would just struggle. And it was very difficult, because they always felt like they needed to belong, but they just couldn't do the math the way that's, they felt that they needed to be doing. And yeah, I understand it's a lot of stress, and it can be a lot helpful, or it can be a lot to take on, but I think it's really important to ask those questions. And I can, I have a vivid picture of memories of students that struggle, and they're just like, oh, throwing away my test, not even going to try. Right. And then these other students, I'm like, you please don't stay after school today, because they would just ask question after question after question. But again, that is that transformation. You see that kid at the end of the year, and you're like, it's amazing. I helped them overcome something that they did not believe that they could do. And I think that's a very, very powerful thing to learn in your life, and especially at a young age. So, all right, let's go into some of your guys' questions that you have, and then we'll get into some of the math questions that I have. So again, just a reminder, guys, if you are first time joining onto the stream, I do go live every Sunday night at 9 p.m. Eastern Standard Time. And I do answer questions that are in the live chat, but also I answer questions not only that are in the live chat, but also that have been pre-submitted. So you guys can see in the chat, there's a link, brianmclogan.com/Q&A that you guys can go ahead and sign up for. Oh, actually, you know what? I can actually add that in there. And then also I have my pre-calculus course, which is still up there as an overview, but I am going to, let me actually see. No. All right. All right, we'll just do that. I kind of wanted, no. All right. Okay. But then also there is, you guys can go to brianmclogan.com/Q&A, where you guys can submit your question, or you can go to the Discord server. All right. So let's go ahead and get into some of these questions. But as far as math questions go, guys, wait till I'm done with these questions. These questions that I have up here have been pre-submitted to me. So I'm going to go through these math questions. Excuse me. I'm going to go through these first before I get into any math questions posted on there. All right. Should we cheat on a pre-calculus test? Well, no, of course you shouldn't. Come on, done. Brain, I'm assuming Brian, you made me pass my test last week. Best person ever. Well, thank you very much, Assad. I'm so happy to be able to help you out. Nate, his trash, says, how do you motivate yourself to study? That's good. It's a good question. And a lot of times, students always ask this. I think the main thing is like, one thing I think it's important to make it a routine as far as studying, right? Like if within your day, like every day, like when you're studying and like, that's just what you're doing. Like it's a part of your job, right? You're just studying like that. You got to make it a routine. Because if you're going to put things off and it's just like you don't want it, then it's going to be very difficult. So try to make it routine. And I think it's better to do it for shorter periods of time more often than longer time. Because what's going to happen, you're just going to procrastinate and you're going to wait till the end, right? And I'd like to say that, to motivate something, you want to be, fun and like do it purpose and like, yeah. But a lot of times we have to take classes we don't want to take and we have teachers, who just don't motivate us. So I think the important thing is trying to make it much of a routine as possible. No, Brianna, Johnny Sims Johnny Sins looks like me, but yes, I'll take it. I had a hard time with word problems on linear equations. Yes, I totally get it. I do have a ton of problems. I don't handle a lot of word problems on my live streams just because they do take so much time. But yeah, I think the main thing is like taking the word problem and then breaking it down into your equations and then just solving it from there. But I do have a lot of problems on there. If you want to go and take a look at my playlist, and like on linear equations, I do have some word problems there. Ben, hey, McLogan, what are your thoughts on the syllabus from the advanced functions compared to pre-calc? Are they the same? Yeah, they look pretty similar to same. Like the one thing on the advanced functions, like a lot of pre-calculus courses have logarithms. I don't have that on my course because that's something in my school. They taught it in Algebra 2 instead of the pre-calculus. It used to be, but it wasn't anymore. But besides that, it just kind of seemed like a more condensed version of the pre-calculus course that I taught. So I think you'd be, definitely inside the course, you'll definitely get some benefit for you. John, why do teachers teach a minimal amount about a lesson, but the activities they give is so hard? Yeah, it's a good question, John. It's, I can't obviously respond for all teachers, but I think there is a, there is an element of a time constraint, right, within the classroom. Just like, I just mentioned you guys, like, you suck at math. Like, a lot of students feel like, oh, you have to learn something by the end of the quarter, right? Which isn't really right, because technically sometimes it's going to take somebody 1 week to understand something, somebody else 2 weeks, somebody else 3 weeks, right? But we have these quarters, we have these deadlines, right? So we have to, have some grades by that time. At least that's what our system is set up for right now. Well, I think that as far as on our system, how it's, set up for right now, I can't even remember what I was going into your question. Oh yeah. Well, again, the same thing like teachers, like we only have so much time to teach what we have to teach. So again, when I'm teaching something, I don't want to just get right into the advanced. And obviously I want to make sure I am teaching it I want to handle people that are like just learning the stuff that need that basic, but also I want to take people through a journey. I want to take them from, basic to advanced. And once you get into more upper level math courses, like it's impossible to teach every single scenario, right? And this is kind of one of those things, like students need to learn how to like problem solve, like or mathematically think, right? And again, like I think building up to math, a lot of times we teach students like, hey, I do, you do, I do, you do, I do, you do, we do, right? And like that kind of idea. And it's just basically the same problem, like swapping out numbers, right? But eventually, I mean, the world of mathematics is so vast, like, it's insane once you just kind of realize how everything is intertwined and stuff like that. And one of the important things we have to have is students to be able to break down and understand a math problem and to be able to problem solve and solve it. And it's very difficult to teach, and it's very difficult to have students do. So yes, I don't think you should be teaching how to do one thing and then say, oh, well, now here's the hardest problem on the test. Like, figure that out, right? No, you gotta build a bridge. You gotta build students up from the most basic to those advanced problems. But I also do feel like it is important to, when we are having students do work, we just don't want to have them regurgitating material, right? That's what we have computers for, is to regurgitate material. We want students to be able to problem solve and think through problems. But yes, I totally agree with you there. It is difficult, and it is a skill, not a skill. It is an art for a teacher to be able to help students go through that, because it's difficult. It is very difficult. Yes, I'm planning on getting there. I got so many videos I still got to make right now. So I hope I'm getting there. Probably not for this year, unfortunately. Word problems just take a long time for live streams, but if you have anything, then you can definitely, Discord maybe. But again, like it's a lot to ask people to like solve a word problem. on the Discord from on there. But I do have, some more problems on my channel, just not a whole lot, just because they take so long to kind of set up. Yes, good, Aiden. Thank you. Well, you're very welcome, Daniel. Yes, I have dealt with many students, but I'll hold the good examples to things. But yes, I've been cussed at multiple times. I don't think anybody's thrown a punch. Thankfully, I got out of the classroom before the slap the teacher craze. But I think I held my classroom pretty well. That I don't think any student would have tried that. But I definitely have been called definitely got called some bad names. And yeah, I'd say really that's really mostly about it. Which I reinforced from high school. I would just say everything from the algebra. I mean, functions, polynomials, factoring, rational functions, like that whole continuity, I think is extremely important for your calculus. Daniel, advice on practice. No, I think you got to move forward. I think you got to take some steps. And again, I think dealing with your habits is the best thing you can do for procrastination. I also think maybe getting out of your element. It's very easy to procrastinate when you're sitting at home and want to watch your same TV show, right? Or, watch your movies or phone. Like, it's more difficult to procrastinate when you put your phone in the other room or you lock it and whatever. Then you get yourself out of your normal element, right? If you always do the same thing every Sunday night, Monday night, whatever else, and you're like, crap, I have all this stuff I got to do. And I'm always going to watch TV. Then literally rip out the cord from your TV and put it, or give your computer somewhere else and lock it and just be or go somewhere else where you can study and do something else. I think when you change up your routine, that can help you at least with procrastination. It's not going to solve it, but I think that can help you. Yeah, Ben, I wait till after I'm done. I'll be able to see from on there. But no, I wouldn't be able to. Find the sum of the geometric series 2 minus 4a. No, I'm not. I would have to go and take more time to be able to look at that. All right. Cool. All right, guys. Let's get on with the math, and then if there's any questions at the end from there, I will answer them for you guys. Okay. All right, guys, just remember, these are all questions that have been pre-submitted to me at brianmclogan.com/Q&A. So if you guys are interested in submitting a question for next week, you guys can go ahead and do it at that link. Or also, if you guys want to go over to my Discord server, you guys can post questions in there as well. And also people will be able to help you guys out. So it is awesome. Again, the link to the Discord is in the chat. And then also for those of you pre-calculus students, if you are interested in joining my course that I created, I talked about it all last week, but you can also just go to brianmclogan.com/precalc and take a look there. All right, let's get on with it. So I'll stop that over here. Okay. How to add and subtract rational equations. I have no idea what type of problem the student wants me to do, because I could do a very easy rational equation. I could do a very small, I have no idea. So I will just do I'm going to just kind of do an introductory lesson because they didn't give me any examples to go through. So let's do a 1/3 plus 1/2. Now, again, you can say, Mr. McLogan, these are fractions. I know, I got it. But actually, let's do 3 examples. Okay, so let's say I had 1/3 plus 1/3. Okay, 1 plus 1/3 equals 2/3. Got it. Okay, that's going to be example 1. I'll get to those in just a second. I got a mindset here coming in here, guys, so play with me. Here I have 1/2 plus 1/3. Well, here you got to get common denominators, right? So the common denominator here is going to be 6. So what I'm going to do is I'll multiply a 3/3 and then a 2/2, right? So therefore now I have a 1/6 plus not a 1/6, a 3/6. 3/6 plus a 2/6, which equals a 5/6. Okay. And then that's the third example, or second example. Now the third example, oops, I don't have room for that. Well, you know what? Let's just go with it on this. So that's fine. We'll just do these two examples. That's what the student will get. So I always like seeing math problems, or at least a little bit more context in what you need help with. So the reason why this could look like this, guys, is let's say I have, x squared plus 3x divided by, let's just say x plus 3. Plus, and let's just do a 2x squared minus 7 all over a x plus 3. Okay, well, guys, if they have the same denominator, it doesn't matter if it's 3 or x plus 3. Those are the same, right? So since those are the same, you just combine the numerator and leave the denominator the same. So I can combine the x squared with the 2x squared, right? Those are like terms. And there's really nothing else I can combine. So my final answer is a 3x squared plus 3x minus 7 all over a x plus 3. Done. Now in this example, I could say, well, let's just do it as a 1 over x plus 2 plus a 1 over x plus 3. Okay. Now, how do you combine these? Well, these do not have the same denominators, right? So we have to find a common denominator. Now, without getting into too much detail, a easy way to find a common denominator is just like I did over here, is just multiply by the other denominator. Again, this is a very simplified approach because that does not always work. But in this scenario, that is exactly what I'm going to want to do. Oh, geez. So in this case, I'm going to multiply by an x plus 3 all over a x plus 3. And then here I'll multiply by an x plus 2 all over a x plus 2. Okay, and again, make sure you multiply in the numerator and the denominator on both of those. So now I obtain a x plus 3 all over, and now we could simplify this, but I'll just leave this as, actually, let's simplify this. If you multiply this through, that'd give you a x squared plus 5x plus 6. And then this is going to be an x plus 2 over a x squared plus 5x plus 6. All right, so then what I want you guys to see is, hey, guess what? They have the same denominator. So now I can combine the numerators. So really, guys, adding and subtracting rational fractions is the same thing with fractions. The only difference is now we're dealing with polynomials than fractions, right? So when you're combining, you got to combine like terms. And the LCD of the denominator sometimes can be a little bit more confusing. But again, if you want to think about just like multiplying here by the other denominator to get a common denominator, that will work. And I think we're going to do another rational expression here coming up. So that's why I'll be fine sticking with the simpler solution here. So this becomes 2x plus 5 all over a x squared plus 5x plus 6. And there you go. How many numbers of pi do you have memorized? 3.14159. And that's as far as I go. All right, question number 2. Finish writing the rational function that would give the stated characteristics. Okay, so it's important here to understand the difference between a vertical asymptote and a point of discontinuity. All right, so if something is non-divisible, right? So if I leave with 1 over x plus 1, then I have a vertical asymptote at x equals negative 1. All right. However, if I had a x plus 2 times a x plus 1 all over x plus 1, what I want you guys to see is the x plus 1s divide out, right? So therefore, we have a point of discontinuity at x equals negative 1. Now, again, the reason why I'm using negative 1 and not positive 1 is because negative 1 is what makes that expression 0. And that's what would make it undefined in this portion problem. So if I have a vertical asymptote at x equals 6, right, that means I don't want that to be divided out, but I do want the x plus 2 to be divided out. So, I mean, literally, guys, I could just write x plus 2 up top. That's going to be divided out, but the x minus 6 is not. Now, in this one, we want it to be, now this can be factored out. Okay, so we want the vertical asymptote, so we don't want x to be divided out, but we want this one to be 2 to be divided out. So again, we could just write a x minus 1 on the top, right? Because we want those to be, we want the x minus 1s to be divided out, which they would be. But we'd have an x still in the denominator here. And again, you could throw some numbers there if you need to, multiple different solutions. Can you do some questions on combining transformations? I have absolutely no idea what this question means, but I don't know if they mean like more than one transformation in a function, if they mean like combining like adding a function to another function, I literally have no idea. So if you have any questions for me on that, questions on combining transformations, I'm just going to go through. I don't know. Usually I won't even write this in there, but I figured I wanted to showcase, like, a lot of times the difficulty. A lot of students are like, hey, why didn't you answer my question? I'm like, sometimes I have no idea what your question means or you want. Other times I know, like, I need more time to like review the concept that you just gave me. And if it's not something I'm completely comfortable with going over on a live stream with 90 people on watching me, then I'm just not going to go through it. Like, you know, I'm not a math genius. I don't remember everything I've ever taught or learned. And then also people give me stuff that I've, you know, some things I've never even seen before. Right. So, but if I'm not 100% confident in I'm going to provide a good explanation for it, I'm usually just going to, you know, move on. So in this question, I literally don't know what this represents or what it have. Can you do some questions on combining transformations for me? But all this, I don't know. I'm just going to graph one for the student. So let's say if I did multiple combining transformations. So let's say I had a 2. Let's just do a absolute value x minus 1. Actually, I got this thing. So let's graph one. A negative 2 absolute value of x minus 1 plus 2. There you go. Okay, so right now we have I'm going to combine some transformations. I have no idea if that's what the student wanted, but maybe it is. So this is our absolute value function, right? So now if I'm going to apply these transformations, a couple things are going on. We have a negative, which is going to reflect the graph. We have a negative outside the function that's going to reflect it about the x-axis. We have multiplying by 2, which is going to be a vertical stretch. And then the graph is going to be shifted 1 unit to the right and then 2 units up. So I think this, if the student is looking into applying this, typically you're going to want to look into, you can move that to actually, I'm not going to go through this because I'm not sure whether, but there's at least multiple transformations going in from there. Can you help me how to factor quadratic equations by grouping? Yes, I will try to do my best here. Now I have to make up a problem though, because you didn't give me one. So let's just do this. 2x cubed, 2x cubed minus a 4x squared plus, let's just see, this would be a x, and then let's see, a minus 2. Okay, so let's pretend you have 4 terms. Now this is not a quadratic trinomial, right? So if you're going to have to be able to factor this out, then if you're going to need to be able to factor this out, ladies and gentlemen, what you're first going to want to do is group the first 2 terms. Group the first 2 terms. All right. And then we're going to group the second 2 terms. So what we're basically doing is we're just breaking them up into 2 separate components. We have basically now we're combining them into binomials, a binomial plus another binomial. Okay. So whenever you have this, even if there's a negative separating them, rewrite it as a plus. So you want to have a plus minus the negative. And I wonder if I could let's actually do that. Because a lot of times what will happen to students is they'll get actually messed up here. So let's do that actually. That'd be a, what I say? X, plus 2. Perfect. I like this. Okay. Now, you don't want to write this. So here's a couple mistakes. Students will do this. No, now you just turn it into a multiplication problem, right? Don't do that. And then some students will do this. No, you want to have this as plus a negative, okay? So, I mean, you can actually get away with this by factoring this one out, but what I would prefer doing is rather than write it like this, or that's a 2, write it like this, 2x cubed minus a 4x squared plus a negative x plus 2. All right, so write it as a binomial plus another binomial. Now, all you're simply going to do is factor out the GCF, okay? So you can see in these 2 components, they have a 2x squared. So I'll factor out a 2x squared, and that's going to leave me with a x minus 2. Now here, again, I want to try to get an x minus 2. So I'm going to factor out a negative 1. And that's going to leave with a x minus 2. Now, again, you could say, where'd the plus go? Well, it's really plus a negative 1, which is really just minus 1, right? So that's why I got rid of the plus. Now, I want you to see what these two components have, right? Now I have a term minus another term, right? Or expression minus another expression. And what can we factor out? Well, we can factor out the common expression, x minus 2. And that's going to leave me left with a 2x squared minus 1. Okay? And therefore, that is factored in that case. Please help me do a composite function. I guess I'll just, again, make one up for you guys. I have composite function. So let's just say I had f of x equals, I don't know, 3x squared plus 2, and g of x equals x plus 1. So why don't we find f of g of x? Okay, so what that means is we're basically, now again, what if I said, what is f of 2? Well, what do we do with this? Well, we plug 2 in for the x, right? So it'd be a 2 squared plus 2, right? And if I said, what is f of star? Well, then what are you going to do? You're going to plug star in for the x, right? Now, again, this doesn't make any sense, right? But hopefully you kind of get used to, oh, well, that's just what you do. Whatever you have the f of, right, then you're going to put that in. So again, this is a 3. Why can't I draw a star anymore? Star squared plus 2. Okay, so when I say f of g of x, then what are we doing? Well, then we're going to put a g of x into the function, right, and for x. Now, again, the cool thing is we know what actually g of x is, guys, in this case. This is a 3 times x plus 1, right, plus 2. And then we can actually multiply this out. Let's see, that's a x squared plus 2x plus 1 plus 2. And then you could distribute a property here. I don't know why I did a problem like this, but whatever. So therefore, you get a 3x squared plus 6x plus 3 plus 2. And then you could rewrite this as a 3x squared plus 6x plus 5. Voila. Oh, crap. I forgot to, I don't remember this formula. Write the next 4 terms. Let's see if I do remember. A sub n equals d plus a sub 1 times n minus 1. Oh, God. Come on, guys. I forgot. I was actually, this is the reason why I forgot that formula. I was trying to see. Hey, I didn't do bad. It was d times a sub 1. Ah, dang it. I was close. See, I told you. That's why I usually don't like to do these problems. Unless I know exactly if I remember. But, all right. So that is going to be, yeah, that makes sense. A sub 1 plus d times d n minus 1. Yeah, okay. All right. So it says write the next 4 terms of the arithmetic sequence. If the first term is 5, so we can say a sub 1 is equal to 5, and d is equal to negative 7. Okay, so write the next 4 terms. So we need to create a formula. So a sub n equals 5 plus negative 7 times the n minus 1. All right, then just apply a little distributive property. A sub n equals 5 minus 7n plus 7. So a sub n equals, let's see, a negative 7n plus 12. Okay, so there's our formula. Now, if we have a formula, how do we find the first 5 terms? Well, we just plug it in, right? So the student also asked this one, so let's just do this. If I said, so new problem, if I said like, what's a sub 1, then you're just going to plug a 1 in for the n. It's kind of like going back to the functions, guys. It's the same idea, right? When we do arithmetic and geometric sequence, it's the same idea. Whatever I have in for my 1, for my n, I'm just going to replace my n in the formula. So 1 squared minus 2. And that's the same thing you do up here. I'm just not going to do both problems. So we could say a sub 1 is going to be 2 over, let's see, negative 1. So that's negative 1. No, that's negative 2. Do your math correctly. Okay. Yes, fair enough. Thank you very much. I should have had that on there. All right. And I forgot to actually put on there. The student says, find and draw. Oh, draw the graph. So it's not factorable. I think what I would do in this case is, so if you're in like a previous class, Algebra 1, you might try to use like finding the axis of symmetry and then plotting points. Actually, you know, let's just do 2 different ways. Let's go old school. This is probably something you probably would have originally found. Would have been, let's find the axis of symmetry. So the axis of symmetry is going to be x equals opposite of b divided by 2 times a. Right? So that's going to be a -3. And then if I want to find f of -3, this is going to be the y coordinate of the vertex. Axis of symmetry / the x coordinate of the vertex. Okay, so that's very important to kind of recognize this vertex here. So the y coordinate is going to be, just going to plug that into your formula, right? So we have a -3 squared plus a 6 times -3 plus 2. And in this case, I will get a 9 minus 18 plus 2. So it looks like you get a -7. So now that I found the vertex is going to be at a -3, -7. Okay, so now that I know what my vertex is, what I would do is I would just pick 2 other numbers I'd just pick 2 numbers either to the right or to the left. Now it looks like I would just create a table, right? So if we had like a table of values, I would just do -2. So right now we have this graph, right? So we have the graph at -3, 1, 2, 3. And then -7, 1, 2, 3, 4, 5, 6, 7. Okay, there's the vertex. So what I'm going to do is I'm just going to pick 2 more points here because, again, remember, this is, you can reflect this across the axis of symmetry, right? That's bad axis of symmetry. So this axis of symmetry, the graph reflects it. So what I'm going to do is I'm going to say, well, what's f of -2? Now I'm going to do the math in my head. Hopefully I don't do it too bad. So that's going to be 4, -12, so that's a -8 plus 2 is a -6. So that's going to be right there. And then again, remember, I can jump this over. Boom. And then I'll do a f of -1. So that's going to be -5, right? And that's a +1. That's a -6. That'd be a -5 plus 2 is a -3. So 1, 2, 3. And then, you know what? And then I can just bounce it over here. And then I could also do f of 0. And f of 0 would obviously just give me a +2. And again, I can just go from there. And again, you could obviously, I could be more detailed if I wanted to. Now, if we wanted to, oh crap, I don't have 2 ways. Let's just go with that. That is an easy, basic way to go graph. You could also, the other way I was going to do, but I forgot I don't have the full screen. What also you could do is just complete the square. And let me just go and do that if I was going to complete the square. And then you could just graph it vertex form. Actually, I got room for this. So if you're going to complete the square, you're going to take the middle term, 6, divided by 2, which would be 3. 3 squared is 9. So I could rewrite this as a x squared plus 6x plus 9 plus 2 minus 9, right? So therefore, that's going to give me a x plus 3 quantity squared minus 7. And then you could just graph it. You know that the only transformations are going to be left 3, down 7. So you just take the regular parent graph, shift it left 3, down 7, and you are done. But I kind of covered myself up. All right. Last question here, guys, and then I will get into any more of your guys' questions that you guys have for me. Fruit. So solve the following equations. All right. So we have a rational equation. And again, it's important here that what I'm going to do is I'm going to factor this out. And this is factorable to a t minus 1 times a t minus 5. Okay. So if you notice, again, kind of like when we were adding and subtracting rational functions, we want to be able to find a common denominator. Now, in this case, we don't want to find the common denominator to combine them, which we could do, right? You could combine these. But in my case, I just like to get rid of the fractions. So what I'm going to do is I'm going to multiply everything times this t minus 1 times the t minus 5. Okay, and what that's going to do is I'm actually going to write this out because I think it's important for people to see this. So what happens when I multiply this out times every single term. Right? And I got the space, and I guess I got the time now. Oh, well, thank you so much, Christy. All right, Christy, I did see your thing, but I didn't get to it. But since you give me a super chat, now I got to go and post you on it. So I'll take a break. Hey, I'm struggling with physics. And I don't mean that I'm only going to answer your question because you give me a super chat. But thank you so much for the super chat. I really, really do appreciate it. And I did see your question. I was going to actually get to it after my math. But since you did give me a super chat, you have my attention. Hey, I'm struggling with physics, and I was wondering if I should have taken pre-calc before taking physics to give me a foundation. I think having the math foundation for physics is very important and very useful. I think you can definitely overcome it, so I don't think it's like absolutely necessary. However, if you're taking like a calc-based physics, then yes, definitely. But yeah, I think it just kind of comes into mental maturity, and you've kind of covered a little bit more of the difficult concepts. So I would recommend it. But I don't think it, like I said, I don't think it's absolutely necessary, but I do think it is important. But yeah, as far as on calculus, do you ask calculus or pre-calculus? Yeah, for calculus, it just depends on what physics you're taking. If you're taking a calc-based or not. Obviously, you're taking a calc-based, you're going to need the calculus before physics. So hopefully that was helpful. All right, and then for this one, I'm going to multiply by, again, t minus 1 times t minus 5. And then equals a 3 minus t squared all over a t minus 1 times a t minus 5 times a t minus 1 times t minus 5. Okay, so what I want you guys to see is the reason why multiplying by the common denominator is so unhelpful, because look at my denominators evenly divide into all of these, right? So now I don't have any more denominators left. So now I have this t minus 5 times t plus 3. So I can multiply that out. That's a t squared. Let's see, this is going to be minus 2t minus 15 minus, make sure you use parentheses here or brackets, whatever you want to do to make sure you have these grouped correctly. Now this one is going to be a 2t squared and then negative 2t, 3t. So that's going to be plus 8t minus 3 equals, now these all divide out. That's going to be a 3 minus 8t squared. All right, so now I got to distribute my negative, right? So I have a t squared minus 2t minus 15 minus 2t squared minus t plus 3 equals a 3 minus t squared. And hopefully you guys notice this is a quadratic. So I'm going to want to get this equal to 0. So let's combine some like terms over here. So this is a negative 2t squared. Sorry. That becomes a negative t squared minus a 3t minus 12 equals a 3 minus t squared. All right, so we can add that. Minus 3, so therefore I get a negative 3t minus 15 equals 0. All right, so then I add a 15 to both sides. Negative 3t equals a 15. Divide by negative 3. T is equal to negative 5. But again, you got to make sure that you check to make sure if it's extraneous. And you can see that it is not extraneous. So if you plug it in, as long as you don't get a 0, then you are good to go. All right, so let's go and check in some of you guys' questions, and then we'll wrap it all up. And get a love from Nepal. Well, awesome. I'm so happy. Nepal, I don't think I've ever had one from anybody, at least that's let me know from Nepal, or at least I remember. So welcome. And what Chris, I suppose, good luck. I want to see what Alexander said. Very nice. Okay. After you take calculus. Yes. Okay. So Alex's advice is most take after calculus. Okay. Ethan says, can you go over little equations? Oh, why do I stop doing this? Hold on. I got to add these in there, guys. So hold on. So that's 1. That was question 2. Question 3. 4, 5, 6, 7, 8, 9. All right, 10. Ethan, linear equation. That's just basically solving for a letter on an equation. So if I had like y equals x minus r divided by s, and let's say solve for r. How are you going to do this? Well, so one thing you can do is let's get everything. What we want to do is undo everything that's happening to the r. So right now, we can see the r is subtracting from x and being divided by s. So the first thing I'm going to do is I'm going to multiply by s on both sides. Okay, that's going to produce a sy equals a x minus r. All right, now this might be a little difficult to write. You're like, how do I undo x minus r? Well, again, you can rewrite this as a negative r plus x, right? And then you recognize, oh, that means I just need to subtract an x. So sy minus x equals a negative r. Now, if I need to get r by myself, just undo. So the main thing with literal equations, I know it's with letters, it gets confusing, but you're just using inverse operations. And there you go. Now you have solved for there. So that's basically it. It's going to be your inverse operations. All right. But it's been too long since I'm not going to be able to quickly go over. I need to review my instruction for integration by parts from there. So unfortunately, it's not something I'm going to be able to quickly and efficiently or effectively be able to go over. What are some careers review about love children? Teaching, babysitting, volunteer, there's a whole bunch of, working in a pediatric anything. There's a ton of opportunities for you out there. All right, guys. So I'm not going to be doing any math stuff, but I'll answer any questions. Dennis, how do you plan on making videos? Saving alpha proofs? No, I don't plan on making any videos or at least I don't have anything set up from here. Difference or the sum of cubes. Yes, if you just want to go ahead and submit for me, then please go ahead and submit on there. I don't have time to I don't have time to go through a problem with right now on the difference sum of two cubes, but if you want to submit them into the link, again, guys, all these questions that I did tonight can be go ahead and submitted into brianmclogan.com/Q&A. So feel free, guys, to always, if you guys will have a question here, then you guys can add it there. All right. Ava asked about z-scores. I haven't done stats in so long, so I'm not very much great help on the z-scores, or at least on the stats. I don't recall going through it. Michael says, education major here. You've inspired me greatly and wanted to teach high school math. How much math did you have in college? Did you end up taking more math classes than your prereqs? Yes. I mean, my prereqs, I have a math, like it was a math major with a degree, it was a weird degree that, but yeah, it was basically a math major. I took a lot of math classes, from on there for that. So, I did take more than I guess my prerequisites, I guess you would have, from on there. And I think it gave me a good perspective of the math and also made me wanted to kind of continue actually my education, in mathematics. What do you suggest if I haven't taught students yet factoring? Going over vertex form and changing to standard form. I would definitely teach factoring before I went into the vertex to standard form. I think that's kind of what I did up here is a confusing to kind of go from if you're going to convert to standard form to vertex form, why does this make sense? Right. And I think that's the number one reason that I get with students is when how do you go from here to here? Right. Students still struggle with that. So I think it's definitely important to teach the factoring component so they can understand the idea and the purpose of creating this perfect square trinomial to get to a binomial squared. So, can I go over trigonometry? Absolutely. Ask me a question. I don't have time for tonight, but yeah, post a question in the, at brianmclogan.com/Q&A, and I'll be happy to answer some questions. How do I solve quadratic functions? You don't have to write it. You can say it for me. Just use the quadratic formula. That's an easy way to follow. And thank you so much. I'm almost getting there. I can try to do my best, submit some questions, and I'll see what I can do. For the following rational code, find the intercepts of vertical asymptotes and then use them to sketch a graph. All right, guys, I will be finishing. I'm not doing any more math. My brain actually hurts right now from all the math. But if you guys have questions, submit them prior to the stream. I will be going live next Sunday night, and I'm happy to answer your questions. For the following are in high school taking calculus. When can I hardly do base? Ooh, Tommy. I'm in high school taking calculus when I can hardly do basic algebra. What is the best way to quickly relearn math up to the calculus level? I would probably do math every day. I think that's the most important thing you need. Like, you have a lot of math you need to cover. I would be doing math every day. Don't be cramming. You need to be doing math every single day. Even if it's math sometimes that you know what you're doing, just practice doing the problems, practice the algebra, practice doing from there. And I would just probably find like some semester like exam videos or semester exam. So you want to be practicing some stuff where you have the answers, right? You don't want to be spending 4 hours getting confused on an algebra 2 problem or topics, right? So I'd probably find, I have some videos. I know there's other videos on YouTube, like, semester exams or long videos that like teach a whole bunch. And I just try to do like 10 to 20 minutes every single day of that, right? And like, as they're doing do their examples and then watch them how they did their examples, and just try to do as much math as you can. That I know you're already doing a whole bunch, so it's a lot of math, but if you can try to break that up and just remain consistent, you can get yourself caught up. I don't know how much that's going to be effective for this year and for calculus, but there is some advice for you. Just same thing. I used to joke with my students, like, literally draw on your mirror and just draw the parent functions and then look at them every single day when you brush your teeth, right? And every single day before you go to bed. And guys, it doesn't take very long to get them memorized. But if you look at them in the morning and at night, right, pretty soon you'll have them memorized. And I would say like roughly within a week, you'll have them memorized, right? So literally draw them on your mirror and you'll be good to go. Actually, sir. Well, thank you so much, Michelle. Happy to have you over from India. Awesome. Sir, you got to watch the beginning of the stream. Okay. Watch the beginning of the stream. Have you ever disagreed with another teacher on how you should teach a concept to students? Yes, definitely. All the time. And especially, it didn't happen as much recently in the last like 3 to 5 years, because I kind of I taught a lot of courses by myself. I wasn't other teachers with that. But a lot of times when we would break down, and that was great. It was actually really good to kind of hear and see how other students how the teachers were teaching it. And that's actually one thing I missed when I was like the only pre-calculus teacher in my school. You didn't have somebody to like bounce those ideas off. Even if you liked doing it your way, it's always good to kind of see how different people approach different concepts or topics. Keep on reviewing them, right? If you did the lesson on Monday, review it on Wednesday, right? And then do it again on Friday. Like, constantly keep it fresh, constantly spiral review, I think will help you out. Just think of inverse operations as like undoing, right? If the function is applying something, the inverse operation is undoing it, right? Think of tying your shoe. The process of tying your shoe can be a function. The process of untying your shoe would be the inverse function. That's a very simple explanation. How to do math when it's a lot of steps in one question? You got to break it down. You got to, I think it's very important when you're doing a big question, especially like word problems, know what you're solving for, right? And then also try to use as much paper as possible. I never got why, I know it's always tough sometimes when you're doing a test, but like spread out your work and don't try to cram everything in, right? Know what you're trying to solve, make sure you can justify your answer, but make sure you use a large paper as much as possible. Yes, I was. No, I had an education degree. It was an education degree with a content area specialty of mathematics. All right. Just keep it short. If you're getting bored, that means your brain is starting to wander off. So do something else, right? Do short little, you're trying to study for too long. So break it up. How hard is it uploading a ton of videos and teach at the same time? Well, I used to upload the videos after school, and I literally would upload 20 to 30 videos a day back in the day. So yeah, I mean, I just taught and recorded, right? And that's literally every single time I taught in the classroom, I hit record, and then I would just upload them at the end of the day. John, I have a ton of videos. Just go and search my playlist. Any tips on not getting bored? You already did that. Yep, just go ahead and submit onto the form and chapter, guys, and I'll be happy to get you for you. You got to stay constant. You got to do math every day, right? You got to stay on top of it. Go from there. Ooh, Evan Fayton, hey, McLogan, just want to say your videos have helped me a lot. So it's a problem I need to solve. Well, you are very welcome. Congrats. Do I have any videos about exponential functions? Yes, I already have that. Dre, go ahead and check. I have a ton of playlists on quadratic expressions. Tio, yes, math is. I would use the binomial theorem for that, and I do have a ton of problems on that, but you can always submit that for next week, and I'll be happy to go over it. We'll submit some questions for you guys. And again, I'm not doing math, guys, tonight, but I will finish it off with this. Because Kevin said, do you have any online classes? I don't have any online like active classes where I'm teaching in person, but I do have my one online course that if you guys are interested for pre-calculus, you guys can check out. Otherwise, guys, hopefully you have a great week. And well, again, if pre-calculus is killing you, go ahead and check out Fighting Turtle, see if it may be helpful for you. But I have a ton of other things for you. And yes, I will do something special for my, I'll do something special for my 1 million subscribers. All right, guys. So, all right, guys, have a great week, and I'll see you guys next Sunday night. Cheers.